Hello, everyone, and thank you for joining us today for a webinar hosted by our Solutions Engineering team. Today, we will be discussing managing secrets, access, and encryption in the public cloud with HashiCorp Vault. I'd like to introduce you to our presenter today, Lance Larsen. He's a Senior Solutions Engineer at HashiCorp. Lance will walk through the basics of Vault and then go into an in-depth demo. Lance and Andy, who is our Vault product manager, will then answer some questions together for all of you. I also want to note that this webinar is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Lance.
Thanks, Amanda. Yes, I am one of our solutions engineers here in San Francisco, and I'm excited to talk to you all a little bit about Vault today. And to start off, we're just going to go into a deck and do a quick refresher on the fundamentals around Vault, what it's good at solving, how we can leverage it, and common deployment patterns today. And then we're going to go through a live demo and show a little bit about how we would actually implement these use cases in a common microservices pattern. So when we look at Vault, what we're really trying to do is find a tool that not only is very first class in the way it can talk to the public cloud, but also support these hybrid use cases as organizations transition their workloads from on-prem to public cloud, and most of these workloads will exist in parallel and possibly in perpetuity as these organizations move forward and deploy into the cloud. So the agenda today, we'll talk a little bit about the problem that Vault solves, and I think it solves it very well, the use cases for Vault. And after that, we'll go into, we'll talk a little bit about the architecture for our demo and do some live stuff with Vault that hopefully will cement some of these concepts. So I think when you look at the shift from static to dynamic infrastructure, and traditionally when we look at how we used to deploy applications, you had three kinds of people. You had developers, you had operators, and you had security folks. And traditionally, these groups had competing priorities and would have to work in the organization together to push software. And in the static and consolidated world, we had application platforms, some flavor of Linux OS or Windows that our apps would be deployed on, and they'd be inside a security and network perimeter running on some kind of physical or virtualized core infrastructure, so maybe bare metal or vSphere. And as we've moved into the public cloud, this world is no longer static and consolidated. We might be running workloads in multiple clouds at the same time in parallel with our on-premise workloads. And in some of these environments, they're essentially zero trust. We might not own all the network pipes that might be traversing more public areas, and at the end of the day, we really don't have a hardened and locked down perimeter where we can sort of have things that are unencrypted and plain text properties files and things like that floating around where people can get access. And we've seen very elaborate attacks mounted from the inside when things like rogue AWS keys fall into the wrong hands. So really what we're trying to do with Vault is find one tool that really can bridge all these environments together and allow operators, developers, and security folks to deploy Vault at speed. So boiling that problem statement into three things we need to do well, it's really eliminating that secret sprawl and finding a tool where we can get secrets out of four flavors of configuration management, Excel spreadsheets, plain text passwords, things like that. And then once we've done that and centralize that sprawl inside Vault, that we have a flexible tool that allows us to store any kind of secret. It might be a database credential, it might just be a static text, it might be a dynamic secret that allows us to create credentials on the fly. And when we have a tool that's centralized and flexible enough to support all the systems we need to talk to, we can then provide governance over it as we're spinning machines up and down and creating credentials and trying to audit and control these workflows. So really what that alludes to is access, secrets, and encryption. And today we'll be primarily focusing on the secrets and encryption piece. But I think Vault has done a nice job. It's similar to our other tools, finding a problem space that's well defined and solving it very well. And we're going to cover a few examples of what these use cases look like for Vault. So starting with secrets management, really we're just trying to store, access, and deploy sensitive information within our organization. And we do have a backend where you can just store static secrets. So these would be any kind of arbitrary string value. But also, and I think Vault has done a really nice job of creating first-class ways to interface with the public cloud and these very ephemeral spin up and spin down environments. And dynamic secrets, essentially you create some root of trust with a target system, and Vault has these roles for the system where it can kind of grant least privilege and have an enforceable lease around that credential. So it's possible to generate a database credential for, let's say, 30 minutes to an hour for a batch job. And once that batch job's ended, Vault will broker that credential and actually remove it and take the onus of doing that rotation and removal away from a human operator. So an example of this would be a Postgres database, and we'll actually show this in our live demo. So as you can see here, I've created a Postgres role, I've called it production. And actually, once I'm authenticated, and this is a CLI example, but it could be done with the API or the UI, I'm able to get that actual credential back. And this is good for, I believe, an hour based on that lease duration. And it's renewable. So if it's a long-running app, it can continue to remove that credential. If it doesn't renew it, that credential gets removed out of rotation. And this is all handled centrally through Vault. So we support many dynamic secrets. We have an awesome community that helps us build these, and as these become more popular, we try to merge these into our main line. So Oracle, as an example, a lot of the database backends, these are already part of our core open source offering. And if you have systems that you're looking to interface with that aren't already available, we have an easy interface for you to build that kind of workflow into those systems. And the next one we'll be talking about is encryption as a service. So when we look at encryption as a service, it's really just, how do we give developers and operators, InfoSec folks, access to encryption services without getting any access to the underlying keys. So what's nice about Vault is you can authenticate in any sort of way that application can talk. Maybe in Kubernetes, you use the Kubernetes backend. Maybe in Nomad, you get a token injected. Maybe you're deploying on bare metal. And you have an app role set up that works with some of your existing deployment tools. But essentially, the keys never leave the Vault. The developer gets an easy API to talk to Vault to do encrypting plain text, getting back ciphertext, and then he or she can go and store that inside the database. And here's an example from the UI, but we're going to show this live. This is a big part of our demo. So very easy to do this, and we have use cases where you can export these keys. But if you don't want to do that and you don't need to do that, the encryption service could be completely consumed via REST API, and the keys never leave the Vault. So moving on, and I did want to talk about this today. We want to actually show this in our demo, but privileged access management I think is important as well, especially when we look at we're creating dynamic instances on EC2 or Azure or GCP. We might need access to that machine for a short period, and then maybe it goes away. I think there's a few other use cases here, but one I think Vault does particularly well is its innate ability to act as a cert authority. We've seen a lot of people build signed key infrastructures where Vault actually, you would store Vault's cert authority on a target machine. And Vault would actually be able to authenticate a user machine's signed, it would be able to authenticate a user machine's public key, return a signed key back, and the target system that's under Vault's management would actually honor that certificate. So in this case, I'm able to authenticate as John Smith, and I put a command line example. And actually, the SSH Vault CLI will handle all this for you transparently. But it's a very easy call that I can make to get my public key signed, and then Vault will actually honor that certificate. And this is all based on OpenSSH. but Vault just does a lot of heavy lifting for you, because it's a very easy to use and to administer cert authority. And so, if you can't introduce any of your machines or users to Vault in a secure way, it doesn't matter how well you can solve the use cases. So we have a lot of flexibility in how we authenticate users and machines. And I think from a rationalization perspective, having a central place where both users and machines can interact with the tool, allows us to, whether we're trying to introduce applications on an orchestrator like Nomad or Kubernetes, or on bare metal with AppRoll, or in the cloud with signed metadata services from AWS or GCP. These are all, it's very flexible in helping us do this introduction across many different environments in parallel. So that wraps up my deck. And at this point, I would like to jump right into the demo. So I'm not sure how familiar you all are with Spring, but I actually I used to do a decent amount of Java work, and I think that the folks over at Spring have done an excellent job with the Spring Cloud Vault library, and that's what we're going to be showing today as our demo application. So walking through this, if I walk through my project, so it's actually pretty simple in what it does. So the main application is just an ORM-based Java app with Hibernate, and we have a very simple API that we have an order class, and this is actually in Postgres, and I'll show you now what that looks like. So we have a table where we store order ID, we store customer name encrypted, product name, and the order date, and this is a Spring Boot microservice. And we leverage the Vault, Spring Cloud Vault library to do a lot of the heavy lifting and communicating with Vault for us. So most of these classes are just for the actual Spring implementation. So I have a basic order class to model out that table. I have an API controller that can return all the orders that I have in my database. It can post new orders, and I can also delete all the orders. And most of these classes, we're just extending the core kind of JPA stuff from the library. But what's interesting here is we have actually in our Bootstrap file, and this is going to happen dynamically in the environment. This is just hard coded for dev. But we have some interesting stuff here. So we have we're doing a token authentication, and we're going to run this app inside Nomad. So for when we actually schedule it, it'll get a dynamic token. But what's cool is Spring is going to completely handle the secure introduction with Vault, and it's actually going to take this token, and because lifecycle is enabled for both our database role and the actual token, it's going to continue to renew these credentials as the app runs. And we really just have one class here that actually communicates with Vault. But we get this Vault Ops class as part of the Spring library, and in a very abstract way, we can do encrypt and decrypt operations. So basically what this is saying is every record that we pull out of the database, we want to decrypt it for the consuming API client, and for every post to the actual library, to the API, we want to encrypt it to the database. So this looks good. I know that this is the functional behavior that I want. So if we look at a few things on the Vault side, we can see that I have HA proxy up, and I'm actually running a Vault in the East region. I've logged into the Vault with the root token, so I can see all the secrets in Vault. And this is where I could do things like get AWS credentials in a self-service way, as an example. So if I configured a role for an S3 bucket, and just to show you how this workflow works, I could actually go in here, grab a dynamic credential, and I could actually validate in real time that this was created by Vault, just so you can kind of see this trusted broker model. So this is a credential that I just created, and the lease for this, if I wanted to remove this credential, I could actually go into the leases since I'm logged in as root, and just go ahead and remove this. So if I revoke this lease, I can go into AWS Console as an example, and I can see that this is immediately taken out of rotation. So if you have apps that need to get access to buckets or humans, you could broker all this access through Vault. And with Vault Enterprise, you could get access to kind of this self-service portal for secrets. So for the actual application, I created this policy called order, which basically just gives us a few capabilities. And this is going to be for our application. So it allows it to go and get dynamic database credentials. It can read on the secret application path, which is just a default for Spring Boot, and it can run encrypt and decrypt offs. So if I actually look at Consul, and we have Consul running in a global environment, so I have Consul in US East, Consul in US West, and Consul in EU West. We'll just be focusing on US East today. I can get a quick holistic snapshot of what we're running. So I have Nomad, which we're going to use for our secure introduction here, client and servers in this environment. My Spring app's actually already running, and I have my Vault up as well. And we're actually using Fabio, which is a console-aware scheduler, to do some load balancing into the AWS environment. So if I go into Fabio, I can see that through Consul, it was able to dynamically do some routing for us and help us get to this API. And in Nomad, I can verify that these two jobs are running in the East as well. So this looks good. And now we can start to walk through some of this code and actually play with our API. So if I go to my console window, so I'm actually already in the EC2 AWS environment where I'm running the Hashi stack, and I can look at all my jobs. And I see, looking at all my jobs, I can see that Fabio and Spring are running. And if I want to drill into the Spring job, I can see that I have one allocation place. And actually looking at this job structure is probably important here. So just to back up, this is actually what we're running inside the AWS environment. So I'm targeting this job at the US East region. I built that Java application that I was showing you and pushed it to the Docker repository. And I'm actually using Nomad to dynamically template some of this information out. So as you saw earlier, when I was showing you this project actually inside Eclipse, when it's running in our actual cloud environment, we're doing some different things here. For one, Nomad is actually going to generate a new Vault token for every job that's placed. And we're going to pull this in the environment variable so it's dynamic. We're actually using Consul to help us find some of the Vault services. And all this stuff is, and this is important because as we, if we think about deploying inside of the cloud environment, right, we don't have the same ability to hard code necessarily where these services are to sort of have, pointers and different things that point to things that are just sort of long-lived, because again, these environments are very ephemeral. So having tools like Nomad that not only can do this, secure introduction piece, right, help us dynamically inject these credentials because Nomad is a Vault-aware scheduler, but also using tools like Consul to help discover these services and create these roles. So this all looks good. And you can see here, this Vault policy I have here ties to the policy that I showed you in Vault. And we have some tagging to work with Fabio. And we've had just some basic resource allocations if we kind of wanted to bin pack this on a single machine. So what we do here is we template out this file and then actually mount it as a volume into the job when it's running. And then to actually configure these Vault roles, it's pretty easy to do. So I created a database role. I created my grant and drop SQL, and then gave some basic parameters around the role. What is the default time to live for that credential, and how long can it be in rotation? And this is all very configurable. So once these roles are set up, it's very easy for me to read out these roles, whether I'm a human being or a machine. So this looks good. This is the behavior that I want, and we can start looking at some of the more interesting stuff inside this environment. So the job is running, and now I want to actually verify that the this dynamic sort of introduction happens. So if I go back and look at what my Spring Boot app does, when it initializes, it goes out and the Spring library kicks in and starts to get some of these values. So it returns a vault token, and because I have the database roles already configured, it's going to go out and get these credentials. So if I actually, using Nomad, I can introspect this job. So if I do Nomad status, if I do Nomad alloc status, I can look at this allocation that was placed. And again, this, think about Kubernetes or running in some other orchestrator. It'd be a similar workflow, but we're showing this in Nomad today. So if I look at this, the task was started. I can see what machine it was started on, what port it was running on. If I actually want to drill into the file system, we can confirm that these placements and this dynamic sort of bootstrapping actually happened successfully. So if I look at the logs and I grep for, what was the word here? Got. Try to make that a little bigger for you all to see. So this confirms that I got a dynamic vault token, and then I also got a user and a password. And this might be a little hard to see. It's hard to zoom this inside of pgadmin, which is just how we're looking at this Postgres instance. But you can see here that this actual vault token, this matches. These two match. So we actually were able to create a dynamic user when Spring initialized, and this wasn't sort of anything we did ahead of time. This was fully managed by Vault to do this activity. So if I go back if I go back into this, we can actually go and look at the running container and confirm this as well. So if I see that this Docker container was up our Spring job, we can drill into this. Oops, I think we need SH. Okay, cool. So this is that main sort of Docker image that I built. And if we look at the bootstrap file, we can confirm that, again, these are not hard-coded values. Everything that we're seeing, that database user that we got, that token that we got dynamically, this was all done driven by this Nomad configuration for the job. And this is essentially how that secure intro is able to happen, is Nomad has a relationship with Vault, and it's able to give us a token that's scoped least privileged just to these policies and do that bootstrapping activity. So if I want to, we can actually try this API now. So I have a load balancer set up in front of that Spring job. So basically, there's a load balancer that sits out and does health checks on Fabio, running in kind of like a high availability configuration. So I think if we run a get in here, it should return us all the orders that we had today. And it does. So this might look a little prettier in Postman. But what I want to call out here is because we have, let's try it in this. So today I have these 4 orders, and I can post new orders to this, which we'll do in a second. But this maps one-to-one with the orders that we have inside our database. But what's cool here is that because we're using Vault's transit services, and you could combine this with some kind of transparent data encryption at the database level. But what's happening here is because we have this class where we're actually, and again, I think it's important to call out that if you were already, say, a big shop that was using Java and had this kind of model, it would be very easy to just create a Vault class and sort of bootstrap your Spring configuration. In fact, really, the only thing that brings Vault into this is that bootstrap YAML file, the dependencies in the class path, and then adding this converter class. Anything that goes into the, like I said earlier, anything that goes into the database gets encrypted. Everything that goes out of the database gets decrypted. And at the API level, this happens transparently to the user. We can just add an order to create a new one. So if I want to, let's see here. let's post. So if I post my order, where are my params here? So I just posted, I'm trying to, I think my, oh, there we go. I just had to scroll up there. So I'm going to add another new order. So Andy's going to join us. So let's say I wanted to order Nomad, and then Andy wanted to order Vault with an HSM. I can post these two orders to our API. We get that immediate acknowledgement back, but none of this information is encrypted till it actually gets to the database level. So I can confirm that these two new orders were placed. I see my order for Nomad. I have some other ones for Amanda, Andy, and myself. And then I can confirm actually that these orders are in the database, but I can't actually see any of this data. And again, you know, we're just kind of trying to create a trivial use case here. And in this case, we're saying the customers who are ordering this, we'd want to protect that. Not only at rest with something maybe like transparent data encryption, but also in flight. And because this ciphertext is protected by Vault, someone would not only have to compromise your TDE layer to get to this, they would also have to compromise Vault for any of this data actually to be useful. And we've done some blogs around this, how you can combine these to have that relationship. But this looks good. So I'm getting the behavior that I want. I'm able to use this Spring API to get the dynamic credentials, talk to the database, and also access the transit services to do all this encryption and decryption on the fly. But you know, let's say we had a use case where we wanted to potentially come in as a user who has access to this value, and sort of again have, you know, users and machines proving their identity to Vault and then acting on the same information. So if I go back to my Vault UI, I can go into this transit backend, which we mounted, and I can actually decrypt any of these values without any access to the underlying keys. So if I wanted to copy, let's say this, I was curious who, you know, bought this Vault HSM, I could take this encrypted ciphertext, put it back in the UI, and decrypt it, and get the name of that customer. So because both the human and the machine user have access to the same policy, even though they're proving their identity to Vault in different ways, they can consume these same services. So I think that's very powerful. You know, when we talk about it from an organizational perspective, doing a sort of tool rationalization across Vault, both for the actors, whether they be humans or machines, and the use cases, secrets, access, and encryption, you know, where we can kind of all do this in one place. So Amanda, at this point, I would love to open, I know we covered a lot of material there. I'd love to kind of open this back up to the audience and potentially, you know, dive in deeper anywhere in the demo where there's questions, or just answer some questions in general around some of the functionality that we saw today.
So we haven't gotten any questions yet, Lance, but for anyone that does have questions or wants Lance to kind of go back through anything, you know, a little slow or anything, please use the questions box to let us know. Here's one, Lance, I'm gonna paste in for you. Lance, do you see that question?
Yes. Sure. So yeah, the question is around, you know, we as an enterprise feature for Vault, we sell enhanced integrations with HSM, and you know, what is that story around how the master keys are secured and any additional sort of synergies we get with those two products. So I think yes, and for those folks who don't know what an HSM is, it's a hardware security module, and in very compliance-driven orgs, processing standards for information such as FIPS 140-2 are areas where customers there's just a need. There's a need to adhere to more compliance-driven, more compliance just around the storage of that data, and things like HSMs give you, tamper-proofing. So if the private keys don't actually ever leave this kind of secure appliance, and if people try to tamper with them, they self-delete. So, and Vault is a piece of software, right? It is not a hardware. So we just, as a piece of software, because of how FIPS is written, often can't adhere to FIPS. So we've built integrations with common HSMs just via the PKCS11 interface to do this. So how this actually works, there's two pieces. We have this concept of unsealing, and an open source, your options are sharding that Shamir key into n number of keys that you give to operators, and they can come together in kind of a key ceremony and do the unsealing. With the HSM integration, the first benefit is you get auto unsealing, and Vault will just use that pin and slot authentication via PKCS11 to go get the master key and unseal itself. So there's certain system backends that are designed to use the HSM in a more additional way, and we call this functionality seal wrapping. So what seal wrapping does is essentially you have you round trip through the HSM before that data is ever stored at rest in for example, Consul. So you can mount, if you specify mount, you can actually say whether you want to seal wrap it or not. And if it's seal wrapped, anytime anything is put into Consul, let's say, it'll round trip through the HSM, and there's an additional encryption that goes through that module before it's at rest. And we've actually had Leidos look at that integration, and they evaluated us around the critical security parameters for key transport and key storage, and determined that we were FIPS compliant in terms of how we were handling that cryptography internally. So, again, if you're looking to tell your regulators a better narrative around FIPS, but you want to leverage the benefits of how Vault allows you to deploy at velocity and in a secure way, customers who have HSM integrations can do this PKCS11 backing with Vault, and then get some of those synergies that I talked about. So again, and it's certainly something that's actually pretty easy to try. AWS now actually has a cloud HSM service where you can get access to HSMs for $1.60 an hour. So the barrier of entry to try out this integration, if you're an enterprise customer, is relatively low. So thanks, that's a good question. One of the next questions we have is there any additional container orchestration integrations planned? This one is specifically asked about Mesosphere, and so the answer to that is no. We today support Nomad with an authentication backend. We also support Kubernetes with an authentication backend, but we don't have. And again, there's lots of flavors of orchestration tools out there. So I think, with the ease of building in things like app roll with some of your existing deployment solutions that you have in place for orchestration, it's generally not that much code to just do sort of your own bootstrap in a Mesos environment, as an example, versus us trying to go out and build integrations for all of those orchestrators. So today, no, there's nothing on the immediate roadmap in open source around that. And then, so the next question is, for Oracle credentials, so I don't actually have an example of generating an Oracle credential, but if you'd like, you can go to our documentation, and there's plenty of examples on there of how you would do that for how you would generate an Oracle credential with that backend. And the next question is, how is open source Vault different from Vault Enterprise? So that's a good question. Just give me 1 second here, and I will bring up just kind of a column comparison of Vault Open Source and Vault Enterprise, and we will talk through that. Just give me 1 second here. Okay. Let me share. Okay, so if you all could see this, so essentially in open source, and open source is very much about those key features for Vault that are around solving the developer use cases. So pretty much everything that we talked about for access, right, SSH, one-time passwords, SSH certs, dynamic credentials, the static KV, all the encryption services, the secure plugin interface, all those features are in open source. And Pro and Premium flavors of Vault are really about, how do we operationalize Vault across large teams, and how do we make it work in a enterprise multi-data center environment where governance and like we talked about earlier, HSMs might be required for compliance. So in Pro gives you that DR recovery, so essentially a warm standby that can be promoted with all the underlying secret state replicated, plus leases and tokens. You get the UI, you can manage the cluster, those replication relationships through the UI. You get unified identity, which is a way to tie someone's authentication through multiple backends to a single identity. So you can manage that policy in one place instead of across all three backends. You can unseal in the UI, and we also have cloud auto unseal, where you can actually use today GCP and AWS to auto unseal the vault and get additional seal wrapping at rest from those environments. And in Premium, we have the HSM integration I already talked about, performance scaling, which those clusters share the underlying secret state and actually can respond to client requests. Mount filters for data sovereignty. How do you restrict certain replication data to maybe adhere to things like GDPR, and then enhanced MFA that's centrally managed for multiple providers. And then you also get our Sentinel policy as code engine on top of it. So again, open source very much about the developer, Enterprise Pro about those large teams, and Enterprise Premium is really that large multi-DC governance and compliance use cases around Vault. So that was a great question. Thank you. And then going back to our next item here, let me pull this up. So the next question: how can we use the KV backend and console as storage for the secrets we intend to protect through Vault? Is it possible to use both the KV and console together? So really, in Vault, when it's running, it doesn't. It's supposed to sort of proxy away the actual storage component of the solution away from the user. And when we talk about things like replication, console console actually has no idea that it's in sort of a replicated environment. All of the core replication logic is built through the actual core Vault code. and it uses Merkle tree indexing and write-ahead logs to stream those replication events and confirm them on the secondary. So Vault doesn't expect its underlying data to be modified out from under it, and that can actually create problems. So you shouldn't manipulate Consul directly in any way when you're using Vault. And the next question is, how do applications talk to Vault without human interaction? So, and that's what we showed, right, when we were looking at that config file. In the Nomad job, that's something that we were declarative about. We declared what policies the application should get. And when that job runs, Nomad has a periodic Vault token that it was using to actually create tokens on behalf of the applications that we were onboarding. So there was absolutely zero human interaction in that flow. And that would be similar in Kubernetes, or if you built your own integration with AppRoll. So for all those secure introduction use cases, there's no actual sorry, I lost my train of thought there. There's no actual interaction that any humans have with those. Those applications and deployments are completely autonomous. The next question is, how can you back up a Vault cluster and restore on a different cluster for DR? So again, we as a company provide enterprise users with out-of-the-box DR, and it's, again, built very elegantly with Merkle trees and write-ahead logging. It does not involve the manipulation of Consul at all. And again, as I was saying, it may appear to work, but tools like Consul Replicate and manipulating Consul directly actually is dangerous and can result in data loss and many other issues that you wouldn't want in a production environment. So really, the proper way to do DR would be to consume it as an enterprise customer, or if you tried to roll it yourself in open source, you'd essentially wind up with a fork of our open source code that acts in the same way. And I do advise people that have DR to use Consul snapshotting just as a backup, because that replication is immediate. So if someone does something destructive, it'll be immediately replicated to all those DR secondaries. But snapshotting alone, the interval that you would have to take snapshots to protect production workloads isn't really feasible. So the correct way to do DR would be to consume it as an enterprise, or you'd wind up with a Vault-aware fork of that application code. So the next question is, when would I use Cubule backend and Transit backend? So Transit backend, as I showed, anytime you have the need to encrypt data at rest and at flight, it's a good choice. The Cubule backend is actually much easier to consume now through the response wrapping API. But anytime you'd want to sort of get a wrapped token that an application would unwrap, it basically protects the value until the final authenticating client can unwrap it. And if anyone intercepts it along the way, the application will get a 400 error. And a lot of people use tools like Elastic and Splunk to actually report on those events. So it's a way of passing a token through systems that may not be totally secure in a wrapped fashion. And again, you can alert on that token if it's intercepted in the process, and potentially revoke it from Vault in an autonomous fashion. What is the best way to secure the PIN on VaultBox to interact with HSM? So I would say that the correct way to do that is through environment variables, and Vault will actually obfuscate the PIN if it's supplied via environment variable. If you have to use configuration files where the PIN and the slot are hard-coded, you should be very careful about what operators can actually get to the file where that information is stored. The next question is, I was intrigued to see the SSH key signing. It's different from the SSH backend I saw last I looked at Vault. What's the different with the new SSH backend? So I'm not sure exactly what that is referring to. It might be referring to the dynamic keys backend that we have, but basically due to some just intrinsic issues with how that backend works, we don't actually recommend that anyone uses that. And the new SSH CA backend actually works where Vault as a cert authority in an OpenSSH setup becomes that kind of user trust CA file, and then you get an API CLI UI way to actually get your own public key sign that you already would have on your machine. The signed key comes back. If you actually look at the cert, it has a validity period and a principal, and then the target machine based on OpenSSH and having Vault CA in that file will authenticate you. So that's not something I had planned for today. If anyone wants to stay for office hours shortly after this, and I believe Amanda will supply that info, we can we can do the SSH CA keys demo in office hours. So please, if you'd like to see that, stay around, and we'll cover that shortly here after this session. The next question is how to verify from Vault that the connection to its storage backend using Consul is still healthy. I would just use Consul health checking to do that. And again, it's important to note that you do need a healthy cluster to use Vault, because as we're aware with Consul, if it's if you don't have quorum or you're in a bad state, you won't be able to make any changes to the underlying Consul state, because the machines won't be able to agree on entries. The next question is Vault suitable for securing the file storage? For example, the uploaded documents by the customers. And so the answer is no. The answer is less about is it secure or not secure. Vault in its storage backend is not designed to be a database. So like the example I showed, you should use the transit back. If you wanted to encrypt documents as an example, you should use the transit backend to either export keys, or depending on how big the documents are, to send those as ciphertext and get, or plain text and get the ciphertext back, and then go and store that in an actual either document repository or a database that's designed to secure that material. And the next question is, how are machines authenticated against Vault, specifically in a dynamic environment where machines come and go on the fly? And so that was one of the examples that we showed, right? We showed a integration with Nomad and Vault, where Nomad actually has a longer-lived periodic token, and that token gives it permissions to create lesser scope tokens. Like in the example that we showed, an order token that gave access to the Postgres database to read and write from that table, and the transit services to do the encrypt and decryption. So, and again, secure introduction is going to differ depending on what environment you're in, but we have a lot of authentication backends to help you do that, right? If you're in AWS or GCP, soon to be Azure, authenticating machine identities with the metadata services that the cloud providers give you in an orchestrator like Kubernetes or Nomad. You could use the Kubernetes or backend or Nomad integration. In Marathon, maybe you write, an init container using app role. Again, so you get lots of authentication backends to help you meet those needs when we're talking about how to authenticate those machines dynamically. And the next question is there an out-of-the-box integration with OpenShift? So OpenShift is just basically managed Kubernetes. So there's no reason that you couldn't, tie into that KA API server that comes with OpenShift. And just recently, we actually became a certified partner on the OpenShift platform. So you're certainly able to use Vault and those backends on OpenShift if you feel like that's your if that is your place where you're deploying those applications. So Amanda, I think we've answered, unless some folks have some more questions, I think we've gotten through the majority of the material for today in the Q&A period.
Yeah, I think so. Yeah, unless there's any final questions, but probably if there are, you could join the office hours that Lance mentioned. If you check out in the GoToWebinar portal under chat, our colleague Brett put the link in there. It's a Zoom link, so it's like a video call meeting, and anyone's welcome to join that. There's going to be a few of our solutions engineers, including Lance, on that call, and that's really a great opportunity to kind of get your individual questions answered and have some of that one-on-one time with all of them. So please join us for that if you're interested. And then, yeah, thank you, Lance. This was a great demo and great questions from the audience. I hope everyone enjoyed today's webinar and was able to learn a little bit more about Vault with public clouds. And thank you to everyone who joined, and a big thank you to Lance for his time today. I also want to mention that we have training partners who offer training of HashiCorp tools where you can go even more in depth. So if you liked what you heard today and you do want to go a little deeper, you can take a look at our training page at HashiCorp.com/training to learn more. And again, those office hours, that link is in our chat. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I will send an email to everyone who registered with the recording link. You can also keep your eyes out on Twitter, where I'll post the recording link a little later today. Have a great day, everyone. Goodbye. Thank you.
Thanks.